Alright guys, we're going to be solving out a question from the second chapter of the Mechanics of Materials by Johnston. And in this question, we have a homogeneous cable of length L and uniform cross-section that is suspended from one end. So I tried to show that cable on the right-hand side. So the cable is actually attached from one side. And in the A part of the question, denoting by rho the density, which would be the mass per unit volume of the cable, by E, which is the elastic modulus. We need to determine the elongation of the cable due to its own weight. And in the B part, we need to show that the same elongation would be obtained if the cable were horizontal and if a force equal to half of its weight were applied at each end. So from the question, we know that the length of the cable is L, so I'm just going to show it as L, and we can call one random point on here, and we're going to call this distance Y, and the rest of that would be L minus Y. And if we try to draw the free body diagram for each of these sections, the bottom one is easier because we're going to be dealing with the weight and also one force. We can just call it F. But if we want to go with the top part of this cable, the top section, we're going to be dealing with three different forces. So it makes sense to go with the bottom one. And basically, if we do sum of all forces in y direction equals 0, let's just call this. We're going to have F minus W is equal to 0, which means our F is basically W, which would be mass times acceleration of gravity. And what we have in here, we have the density, and we know that density would be mass over the volume. So if we want to find the mass, we basically have density times the volume. We know we have a cylinder, so the volume would be the area times the length, which our length in here would be L minus Y. So basically rho times A times L minus Y. So we had our formula, which was delta, or elongation, was force times length over A times elastic modulus. And basically we're going to have derivative of delta would be F times dl. We call our moving in vertical direction y. So it's going to be dy over AE. And we're just going to put the force that we found in the previous part, which was basically mass times g, so rho g a L minus y, and we can do our integral after this on each side. So let's just write it. D delta is equal to F, I'll just show F in here, rho g a L minus y dy over AE. The A will be cancelled out. And now we can do our integral on each side, knowing that our y-axis will start from 0 to L. So basically L delta is equal to, I'm just going to put everything in here, rho g L minus y dy. We can take out the rho g because it's the constant part, so L would be Ly, and for y we're gonna have y squared divided by 2. The 0 is gonna make everything 0, so 0 to L. So our delta would be basically rho g L squared minus L squared divided by 2, or we are missing one E in here over E, and same in here. This would be half of L squared, and this is going to be the answer for the A part of the question. So in the B part of the question, we had two conditions where the cable is horizontal, and also we have half of the force applying on each side. So this time our weight would be basically rho GA times L, and we have our formula for elongation, which was basically FL over AE. So our F would be delta EA over L. And the question is saying if we had the same elongation from what we found in the previous part. So basically this one, our F would be 1/2 of rho G L squared over E times E times A over L. So the elastic modulus will be canceled out. We can cancel one of the L's too. And what we're going to end up would be 1/2 of rho G L A, and this is going to be the weight that we have. And we can see that our force would be 1/2, which was the condition that we have. So for the same elongation, we got the force half of its weight. And yeah, that's pretty much everything for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.